Asteroid may not hit Earth in 2032, but it will come back. In late 2024, astronomers spotted asteroid 2024 YR4 on a trajectory that could potentially threaten our Earth. This observation triggered a fervid series of observations of the object, possibly as big as a football field, to determine that it will not hit. However, an impact on the moon cannot be ruled out. Can you imagine? And then in January of this year, the near approach of the asteroid, perhaps a million times more massive than massive, went almost unnoticed. We didn't notice it. The asteroid 2024 YR4 has a diameter between 40 and 90 meters. That's about, 300 feet. And it was referred to as a city killer capable of causing regional damage and affecting the climate. The larger asteroid 887 Alinda is over 4 kilometers in diameter and could cause a global extinction event. Alinda remains just outside Earth's orbit, while 2024 YR4 does cross our orbit and still could impact our Earth. However, this won't occur in the foreseeable future. Doesn't it seem to you that we're getting a lot of asteroids? I guess their telescopes are better. They can thankfully observe them instead of missing them. Now, asteroid orbits, both 887 Alinda and 224 YR4 orbit the Sun 3 times for every time the massive planet Jupiter goes around once. Since Jupiter's orbit takes 12 years, the asteroids will take 4 years to be back on similar paths in 2028. These special kinds of asteroids are dangerous since they come back regularly. And we're already in 2025. 3 years is nothing. Alinda was discovered in 1918 and has made several sequences of near passes at 4-year intervals. 2024 YR4 has made what NASA considers close passes every 4 years since 1948, but was only recently noticed. Not since the 1970s has so much attention been paid to asteroids with a 3-to-1 relation to Jupiter. Such relationships had already been noted as a curiosity by American astronomer Daniel Kirkwood in the late 1800s. And working with very sparse data, since few asteroids were known at the time, he noted none went around the Sun twice for each Jupiter orbit, nor 3 times, nor in more complex ratios like 7-to-3 or 5-to-2. These so-called Kirkwood gaps are not obvious since they show up only in plots of the average distance of asteroids from the Sun. The gaps remained a mere curiosity of the solar system for about 100 years. The employment of new computer technologies to calculate orbits revealed the effect of resonance to scientists in the 1970s. Resonance occurs when asteroids appear to move at the same time or a multiple of or orbit speed of another external object, in this case, the planet Jupiter. The Kirkwood gaps are explained by asteroids similarly interacting with Jupiter to leave the asteroid belt even while their average distance from the Sun does not change. By dipping into the inner solar system, where we are, of course, these asteroids are often removed from the gaps in a very simple way by hitting an inner planet like Mars, Venus, or Earth. Scientists also found that these gaps were not completely empty. Alinda, for example, was in the 3-to-1 gap. Many more such asteroids have been found, and they are generically named Alindas after the prototypical first discovery, whose name origin is a bit obscure. The return of the asteroids. If the bad news is that Kirkwood gaps are due to asteroids hitting inner planets, including our Earth, can it get much worse? For Alinda-class asteroids, it does. Alindas follow their pumped-up orbit every 4 years, so properly aligned Alindas get a chance to hit our Earth about that often. Near passes of these asteroids tend to happen spaced by longer intervals, but when aligned, they come back several times with 4-year spacing. A limiting factor is how tilted their orbits are. If they are quite tilted, they are not often at a height matching Earth's, so are less likely to impact our Earth. The bad news about that is that both Alinda and 2024 YR4 are very nearly in the plane of Earth's orbit and are not tilted much, so are more likely to impact us. The resonant pumping stretching the orbit both inward and outward from the asteroid belt has already made 2024 YR4 cross Earth's orbit, giving it a chance to impact. The much more dangerous Alinda is still being pumped. In about 1,000 years, it may be poised to hit our Earth. One piece of good news is that 2024 YR4 will miss us in 2023, but by coming close, it will be kicked out of its Alinda orbit. It will no longer come back every 4 years. However, getting an orbital kick from Earth, its orbit will still cross ours, not just as often. The current orbit shows a somewhat close approach farther than the Moon in 2052, and beyond that, calculations are not very accurate. Now, the other asteroids, although Earth is a small target in a big solar system, it does get hit. If 2024 YR4 managed to sneak up on us in 2024, can other asteroids also surprise us? The last damaging one to do so, apparently undetected February 15, 2013 over Chelyabinsk, Russia, injured many people when its shockwave shattered glass in buildings. And in 1908, a larger explosion took place over Tunguska, Russia's Siberia, a remote region where huge areas of forest were devastated, but few people were injured because not many people live there. So we have to keep watch while astronomers work diligently to survey the night sky from Earth's surface. Space-based surveys like the upcoming Near-Earth Objects (NEO) surveyor can be very efficient in detecting asteroids. They do so by their heat infrared radiation, and being in space, it can also study the daytime sky. According to Amy Mainzer, lead in the NEO surveyor, near-Earth orbit, we know of only roughly 40% of the asteroids that are both large enough to cause severe regional damage and closely approach Earth's orbit. Once launched in late 2027, NEO will find, track, and characterize the most hazardous asteroids and comets, eventually meeting the U.S. Congress-mandated goal of knowing 90% of them. Among asteroids, we must pay special attention to resonant ones, such as 2024 YR4, because eventually they will come back to us. This is from the conversation by Martin Connors, Professor of Astronomy, Mathematics, and Physics, Athabasca University, on Science Alert. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.